In this video, we're going to be talking about vertical angles, which is one more type of angle relationship. So our essential questions are, what are vertical angles and how do you use vertical angles to find missing angles? So what are vertical angles? Angles that are across the vertex from each other when two lines cross are called vertical angles. So you have to have two lines crossing to have vertical angles. So they're like the angles that are mirror images of each other. They're kind of reflected across the vertex. So if you take a look at this diagram here, we have two lines that cross, and what that does is it creates four angles. We'll call them creatively angle 1, angle 2, angle 3, and angle 4. So here is our vertex right here. And then that's the key to vertical angles. Now, vertical angles doesn't have anything to do with maybe your understanding of the word vertical, like vertical is up and down and horizontal is left and right. This isn't the vertical we're talking about. We're talking vertical as in pertaining to the vertex. So it's across the vertex. They are vertical to each other. So it has to do with the vertex. So we have these groups of or pairs of angles that are kind of reflections of each other, and those are called vertical angles. So we would say that angle 1 and angle 3 are vertical angles because they're across the vertex from each other. You can see they're kind of mirror images of each other if the vertex is a mirror. And then angle 2 and angle 4 are vertical angles to each other. That's how they are related to one another. They are vertical to each other. These angle relationships are called vertical angles. So they're kind of mirror images of each other. So what's special about vertical angles? Well, vertical angles will always be congruent. Now, there's a big fancy word for geometry, congruent. If you don't know what congruent means, I've got the definition right here. Congruent means they're the same measurement, or in other words, they're equal in geometry. It's a big fancy word for equal. They're the same thing. And we even use a special symbol for it. It's the equal sign with a little wave over it there. So that is the congruent symbol. So vertical angles will always be equal to each other. And that's a nice fact to know when we're trying to find missing angles. So here I have this diagram, and I've got, again, two lines crossing, and I've got a bunch of angles here. So I have angle AXB is congruent to angle CXD. That's what this statement says right here. Angle AXB is congruent to angle CXD. That means they're the same measurement. So if we, or sorry, AXB and CXD. I hope I said that right. So if we trace these angles out, here's AXB. Angle AXB is right here. And angle AXB is 56 degrees. And if we look at angle CXD, we'll see that that angle is also 56 degrees. So they are the same. They are equal to each other because they're vertical angles. And then likewise, angle BXC is congruent to angle AXD. So again, BXC is right here. Here's BXC. That's this angle right here. And angle AXD is right here. And they are both 124 degrees, so they are congruent. They're the same thing. So when you have those mirror images across the vertex from each other, they are called congruent, or they're the same measurement because they are vertical angles. So how can we use that little trick, in fact, to help us solve problems? Well, pretty easy. When we have this diagram here, if we know that this angle right here is 42 degrees, and here's our vertex, this angle right here is 42 degrees, what is x? Well, that should be a no-brainer now that we know what vertical angles are. Vertical angles are going to be congruent. These two angles are the same thing. So x equals 42 degrees. Very easy to solve those types of problems if you just know angle relationships. And then again here, what is going to be the measure of angle z? Well, here I've got two angles that I know, but which one of these two angles is vertical to angle z? Well, this one right here would be across the vertex from it. So z is the same as this angle right here. So z is 110 degrees. So again, a couple of examples there of how we can use vertical angles to help us solve this problem. So here we have two lines crossing, and I know one of the angles that are created. I don't know the other three. How can we use what we've learned about angle relationships to find the measure of all three missing angles? We really can do this, and it's really quite easy to do. So I'm going to list my missing angles here. I don't know what they are. Are there any angles that you know right away? Well, if I know vertical angles, I know that this angle and this angle are across the vertex from each other. They are mirror images of each other. So I know that y is going to be 41 degrees as well. These two angles have to be congruent. So I know that y is 41 degrees. Now how do I find x and z? Well, we're going to have to go back to what we've learned before about angle relationships. What's special about these two angles right here? The x and the 41. You'll see that they form a straight angle. What do we call that? Those are supplementary angles. These two angles are supplementary. So I know that x plus 41 equals 180 degrees. So now I'm going to apply what I know about supplementary angles. I know that x is going to be 180 minus 41. So x equals 139 degrees. Now I know this angle is 139 degrees. And then how do I find z? Well, if I know x, z is across the vertex from it. They are mirror images of each other. So I know that z and x are the same angle as well. So I already know what z is. Z is 139 degrees as well. So really, when you have two lines crossing, you only have really two angles and then two copies of those angles. So it's very easy to solve these types of problems if you just know angle relationships. We can use what we know about supplementary angles, and we can use what we know about vertical angles to solve even more types of angle problems. And that is vertical angles and how we can use those to find missing angles.